Have you noticed that when you try to use AI for coding, it actually lowers the quality of your work? That's because AI only helps when you point it at the right problems. Most developers don't know what those are, so they waste time fighting the tool instead of getting leverage from it. So in this video I'm going to reveal 3 AI workflows senior backend engineers rely on. I'll show you how easy it is for any backend engineer to implement these workflows in their daily work and demonstrate how they perform in real time. By the way, all prompts and comments from this video and my entire AI engineering workflow is free to get in the description. To install them into your cursor or Cloud Codes project, just use one command and you're all set. Your value as a backend engineer comes from making sure the software you build is secure, optimized, and can handle hundreds, thousands, or millions of requests smoothly. I remember once being in a technical interview and we talked about testing. The interviewer asked me, how do you know your code works without tests? And then I realized that without good unit test coverage, you can't actually be sure if your code even works. And that's before we even talk about how it performs. Years ago, when I was a junior, my team released a feature that let users export data. Most clients had 3,000 rows to export, and things worked fine with about 3 seconds latency. But after some time, a client with over 20,000 rows came along and the export didn't work at all. They couldn't get a response from a server and they were understandably frustrated. But a single test that covered this kind of case would have told us we needed a different approach from the start and saved a lot of time and money. Now, writing tests isn't fun. It's repetitive and boring. But this is where AI really shines. Its strength is in following well-structured patterns and frameworks, which matches perfectly with testing. AI can save you hours, but to get that, you need to have your testing strategies, infrastructure, and patterns well set up and clearly documented. Both you and AI need to understand the software and the business requirements it covers. So first, tell AI to observe the feature you're working on and show any relevant requirements you've implemented. This helps AI build context and get deep into the details. It's like the AI getting ready to discuss the feature. It investigates but doesn't jump to action yet. Next, tell AI to write comprehensive unit tests following your existing test patterns for each component. The real secret is to then tell AI to run the tests with your command, fixing or tweaking the code and tests until they pass. Or if AI finds a real problem in logic, it stops and lets you know. Honestly, before this, writing tests used to take me half of my time, and this use case alone makes me twice as productive. But keep in mind that writing good tests is only possible if the underlying code is clean, structured, and decoupled. Vibe coding is dead because you can't really let AI do whatever it wants. Even creating tests. You need to review all tests to make sure they match your software expectations and actually make sense. Also, watch out for missing edge cases or any important use cases that AI might have missed. Use AI to test software by following this framework. First, set up your testing strategies. Have AI observe the requirements. If you downloaded my setup, just use observe command. Generate and pass the tests. That's /test command in my setup. Review the tests and add more as needed. But using AI to write tests isn't such of a secret. What if I told you there is a way to use AI that actually forces your and AI-generated code to be better from the very start, before you even write a single line? This sets clear boundaries for your implementation and tells AI exactly what behavior you expect, so it can evaluate each component it implements for correctness. This is possible if you use AI to write tests before you write the feature. This is called test-driven development, or TDD, and some tech teams already use this. But even if you never tried TDD, because it felt too much overhead, AI makes it easy to get the benefits from it without boring process of writing tests for non-existent code. AI doesn't get bored. So the AI TDD workflow looks like this. Observe the requirements, create unit tests for these requirements, Implement the feature continuously running tests to evaluate correctness. This way, you get clean, tested, and high-quality code faster. Good tests can prevent a lot of bugs, but eventually you're gonna get one. Depending on the quality of the project, debugging experience can be bad or awful. So most engineers try to avoid debugging and immediately ask AI to fix it. I used to do the same, just offload the problem and hope AI would fix it. I used to do it a lot, and one time it went really bad. So we released this feature to production and real users ran into latency issues. It just had to be fixed fast because it was almost unusable. But this API was complicated, heavily relying on database query performance and time complexity. And on the first glance, everything looked fine. So I got lazy and asked AI to fix it. It immediately tried adding indexes to the database that in the end weren't even used by database engine, and rewrote parts of code making it much less optimized. After wasting time on this, I went back to my own debugging process that always starts by proving assumptions before trying to implement a fix. And that's when I realized this was the step AI was missing, the proving of the problem before fixing. After we structured the debugging workflow to include the step, AI got a lot better at debugging. Now it can handle complex problems and massively boosts my productivity, saving me from long, late nights. Here is how you can do it too. First, don't ask AI to fix bugs if you already know what the problem is at all. If you don't, tell AI to observe the module where the bug happened. Again, it's /observe command from my setup. Ask AI to debug and find the root cause, but don't let it fix anything just yet. For that we have /debug command. Then make AI prove its assumptions with unit tests following the same testing strategies we used in the previous workflow. If the test doesn't confirm the issue, AI just keeps investigating. Remember, debugging is a process of finding problems, not just fixing blindly. Letting AI fix right away usually leads to bad choices and more trouble. Also, AI tend to make mistakes, false positives, or miss business logic, which means you have to review its work carefully. Using AI effectively means guiding it through the investigative debugging process, combining your expertise as a professional backend engineer with its speed. That's the best way to get fast, reliable bug fixes without falling into the new traps. But what I notice is that even though bugs always happen, well-architectured systems are way more stable, and the best backend engineers spend the most time planning them, and as a result, way less time debugging. And having a group of colleagues to discuss and criticize decisions that you make certainly helps a lot with that. But imagine having a senior engineer from a fan company as your personal consultant, someone you can ask anytime to validate your ideas and guide you. How much better do you think your work would be? Let me walk you through such a case of mine. So we were building the system that crawled websites and checked them for problems. My job was to create a pattern for custom checks that would run on every page of all websites every day. This was really important because if the checks missed something or weren't efficient, the whole system would fail or give the bad results to users, so it had to be done right. I had a few ideas on how to set up a pattern for these checks. Some looked good, others didn't, but I wasn't sure which would actually work best, and I wanted to avoid making costly mistakes later on. That's when I brought AI into the loop, and it started asking me sharp, on-point questions that made me think deeper about the problem. Its questions helped me see things from a different angles and steer me toward the right solution, not doing that instead of me. Thanks to AI's guidance, the project turned to be a success. Now the system works smoothly and reliably, and a big part of that success came from having better design decisions early on. That is very similar to what Google's engineering lead said about their AI workflow. They start with AI-generated system diagrams, Ask questions until they understand their architecture. Create detailed change plans. Break down into AI manageable chunks and maintain context throughout. This is the biggest difference between middle and senior engineers. Middles rush into coding without thinking about future needs, but the senior will plan carefully and spends way more time on the step than you can imagine. Because if you provide detailed and clear plan that solves the problem in a clean way, implementing it is no longer a bottleneck. So here is how senior engineers use AI to validate their decisions. First, ask AI to observe the code they are working on. Next, ask AI specific and critical questions like, will this scale under heavy load, and is this pattern extendable for similar features? They don't just accept AI's answer, they make it prove its claims and shows how anything could go wrong. Using AI this way helps avoid bad decisions that might cause problems later. I used to work with ex-Google engineers and learned a lot from them, even if some feedback was tough to hear. But think about this. AI has read and stored almost all knowledge on the entire internet. This kind of broad knowledge makes it maybe the best consultant you can get. The only catch is knowing how to ask it the right questions. Today we covered 3 AI use cases that amplify your potential as a professional backend engineer. If you want to get our full AI workflow with all prompts, commands, agents, and rules that seamlessly integrates into your coding setup, the link is in the description. It's free.